Okay, in the background you're listening to Eye of the Tiger by Survivor. Has 71 million views on YouTube, so it must be good stuff. Check it out. But powers of I, not that difficult if you think about it. So I to the first is just I. I squared comes out -1. I to the third equals -I, and I to the fourth equals 1. Now, I'm going to be asking you for different powers other than just 1, 2, 3, and 4. But we're going to be able to see a pattern here. So let's discover what each one of these equals. I to the fifth is just I to the fourth times I, if you think about it. Now don't forget what I to the fourth is. I to the fourth equals 1. So 1 times I is just I. Think of this one. This is I to the fourth times I to the second. That would make I to the sixth. But I to the fourth is just 1. 1 times I squared is I squared. So I to the sixth is really just I squared, or -1. Same thing here. I to the fourth times I to the third would give me I to the seventh. Again, 1 times I to the third is just I to the third, so that's -I. And then this one's I to the fourth times I to the fourth, and I to the fourth is just 1, so that's literally 1 times 1, which is just 1. So what you realize is that it repeated itself. Okay? Now, if we wanted to look at the next one, since we see this repeating pattern, we can kind of go sideways now. So I'm just going to recopy these. This is I, -1, -I, and then 1. So then you can think about 9, 10, 11, and 12. It's going to be the same thing. I, -1, -I, 1. Now down here I could think of this as I to the fourth squared times I. I to the fourth squared is I to the eighth. But it doesn't really matter because 1 squared is just 1. So this term right here is still 1, just like this was. So 1 times I is just I. So I can always put this in terms of, this would be I to the fourth squared, so that's I to the sixth, or sorry, I to the fourth squared is I to the eighth, and then I need 2 more to get 10. Again, that's just 1. 1 times I squared is -1, and so forth. So I can keep proving that to you all the way down the list. So what do we notice about this pattern here? Well, as we go across, if your exponent is a multiple of 4, it's always going to be 1. All right. You also might think that if it's even, but not a multiple of 4, it's going to be -1. And then for the odd ones, you can just kind of think of how far are you away from C to the fourth, or I to the fourth, or I to the eighth. So if I have I to the seventh, I'm 1 away. Sorry, I have a cold. If I have I to the seventh, I'm only 1 away from I to the eighth. So I can just think about being 1 away in that pattern. So I get -I. And so forth. So let's try a couple here. So what is I to the 63rd power? So if I want to do this, one way I can do it is I can think about 63, and if I divide it by 4 and think about the remainder. So 4 goes into 63 15 full times. Alright, so 15 times 4 is 60, but then I have a remainder of 3. So if you think about it, 60 would be in this last row right here, because 60 is a multiple of 4. Alright, so if I'm 60's here, 61, 62, 63 would be right here. So this just equals negative I. So you can, if your remainder is 0, it's going to be in that row. If your remainder is 1, be in that row. Remainder 2, remainder 3. So that's just one way to do it and think about it. The other way you could think about this is I to the 4th. Like I said, it goes in there 15 full times. That's just I to the 60th. Alright, times, that only gets me 60. I need 3 more. Now, why is this powerful, setting it up like this? Well, I to the 4th is just 1. 1 to the 15th power is just 1. So this is really 1 times I to the 3rd, and I to the 3rd is negative I. So either way you look at it, I get negative I